Alright, so we need to draw a sketch of the locus of z given by the equation of the arg of z take away 1 and take away the arg of z plus 1 is pi on 4. Alright, so we're going to label them A, B and theta. Alright, just make it a bit easier with my notation. Alright, so arg of z take away 1 will be there. Arg of z plus 1 here. Okay, what it's saying is that it's going to form an angle at pi on 4 when it subtends the circle using the points A and B. Alright, so that's the full circle at the moment. Alright, because what I'm about to show is that if you pick a point P on that circle, okay, so you pick point P so that it always subtends an angle of pi on 4 on the chord AB. Alright, and that's why it will form a circle. So that result will be theta. Okay, and the angle, sorry, is not the point, it's actually the angle. Okay, for the argument, make with the positive x-axis over to the ray. So, from your exterior angle results, we know that A is going to be theta plus B. That's the exterior angle result. Okay, so that means that your theta, bringing this over to the other side, A take away B, so it matches your formula, that's why it forms the angle there. Okay, so in other words, pi on 4 is going to be arg of z take away 1 take away arg z plus 1. So far, but we need to find the centre and the radius so we can finish the answer for the locus. Okay, so yes, it asks us to sketch, but if it asks you to just describe the locus, you need to have the information about the centre and the radius of the circle, as well as any other condition for the locus. Okay, so somewhere here we're going to have the centre of the circle. Okay, now it will be on the imaginary axis because the distance between these two parts of the circle are on the same horizontal line. Okay, so you can understand the geometry, that centre will be there. Alright, what I'm going to do is finish that there. And that will give me the radius as well. And then drop the perpendicular down. We know the axes are perpendicular, and we can use that property to help us with the next session. Right, so drawing, blowing that up, so we got B, point B, point A, this will be O, and call that M the midpoint of AB. Okay, so any 3 points will form a circle, okay, and using my circle theorems, I can justify that when you drop the perpendicular down, these two must be equal in length. Perpendicular bisector from the apex to the triangle. Okay, so angle AOB is going to be pi on 2. Alright, so using the circle geometry property. Okay, so that's going to be pi on 4, so the angle at the centre is twice the angle at the circumference. Okay. Right, now because this is a perpendicular bisector as well, split pi on 2, we have pi on 4 on each side. Okay, so we need to find the distance OM, because what that will provide me is the imaginary value that gives us the centre of the circle up there. Okay, how am I going to do that? Trig. Okay. The tan, so your basic right angle trig. So this is back to year 9 work. Tan pi on 4. Okay, it's going to be the opposite here. AM and BM. Now, the distance, sorry, before I do that, what's the distance from M to A? 1, okay? Because this is arg z, take away 1, arg z plus 1. So, these two distances can be 1, 1. Right, so the opposite over the adjacent, so 1 over OM. Okay, and tan pi over 4 is pi on 4, 45 degrees, so tan pi on 4 is 1. Okay, so I'm going to swap that over. So OM is 1 on 1. It's 1. So that distance there, and of course I've recognised this here as a isosceles triangle. Because of angle sum of the triangle. Okay, that's the other way you could do it. That distance is 1. So we know now the centre of the circle is 1 unit up the imaginary axis, or a centre of I. But now we need the radius. So OA will provide the radius of the circle. Okay, so either using Pythagoras or using trig again. Okay, so OA is going to be the square root of 1 squared plus 1 squared, and this is Pythagoras, is root 2. So that is your radius of this circle. Alright, so therefore, locus is the major arc above the x-axis that subtend an angle of y on 4 with the chord AB. So, yep. Come back for a moment. Finish this. Send angle of pi on 4 with the chord AB. What else is the condition? Yep. Of circle with centre of I and radius of root 2 units. Okay, and the other thing we need to say, because remember the argument is not defined at a point, so we need to make a statement with that as well. Okay, so note that note that point A and B are not included. Alright, so to summarise, when you have the difference of two arguments, it will produce an arc of a circle, and the length of the arc will be dependent on the value of the angle. Okay? So you think about the centre being shifted up one, so you're going to get a major portion of that arc meeting at the x-axis. As to why we are not considering the below the x-axis, there's a reason for that, and I'm just processing that. So let's do a quick sketch so we know that it's centre at I, the radius of root 2, and of course we have open circles there. And that is your locus. But that finishes complex numbers now.